When we talk about numbers, there are actually four types of numbers: nominal, ordinal, interval, and ratio. We'll talk about each one of these individually. Nominal, as the word implies, actually means in name only. So this data is generally list of names or categories with no order or ranking. An example might be the list Taos, Acoma, Zuni, and Cochiti. That are actually four Native American Pueblo tribes of many that are in Arizona and New Mexico. There, of course, is no order to those names. There's no ranking. They're just four names, and that's nominal. When we start talking about ordinal data, then ranking does exist. But calculations such as averaging or difference are meaningless. A good example might be that 23 people like drinking Coke very much. We might have 20 who just like Coke. We might have 5 that don't like to drink Coke, and we might have 7 that really don't like Coke. So we have data. All right, we have 23, 25, 7. We have numbers now, but it doesn't really make sense to average these four numbers. Numerically, I suppose we could get an average, but what would it actually mean? It would mean nothing, which is why ordinal numbers are meaningless. We can't average numbers like that and get any meaning. And the same is true if we subtract, 5 from 20, the number of people who don't like Coke from the number of people who do like Coke. Of what meaning is that? Really, there is none. So that's an example of ordinal numbers where, there is a ranking, there's an order, but calculations really don't make sense. The next are interval data. For interval data, calculations become meaningful, but 0 in the scale being used is arbitrary. Therefore, the ratio of numbers is not meaningful. This is a difficult one to figure out sometimes. An example is much easier to deal with. For example, temperature. We could have 10 degrees Celsius and we could have 20 degrees Celsius. These might represent 2 different days. Now, we could average those 2 days and get, on average, it's 15 degrees Celsius, and that does have meaning. You could subtract one from the other and say, all right, there was a 10-degree difference between the first day and the second day, and all that has meaning. The ratio of these numbers, right? 20 degrees is, of course, twice as big as 10 degrees. Is a 20-degree day, is there twice as much heat as a 10-degree day? The answer is actually no. It doesn't have twice as much heat. And even if we talk about perception, is a 20-degree day feel twice as hot as a 10-degree day? It doesn't feel twice as hot. So that ratio of twice is not meaningful. Right? And the reason is because the point of 0 is an arbitrary point, set at the freezing point. But, that's not 0 heat. Because there is still heat when you're at 0 degrees centigrade. You need to take chemistry. Hopefully you've taken chemistry at this point and you understand that. So that's an example of interval numbers. So we need to be kind of careful about those sometimes. And of course the last type are the ratio numbers. In this case, calculations are both meaningful and the ratio values are also meaningful because the 0 does in fact represent a complete absence of quantity. All right, we talked about how temperature, when you talk about 0 degrees centigrade, that's actually not 0 heat. It's not complete absence of heat. There is still heat present. So an example might be in one river, the trout average 8 inches long. In another river, the trout average is 4 inches long. And in fact, the ratio of 8 to 4 is twice, and in fact, the fish are in fact twice as long. And if you think about it, a fish that's 0 inches long is not a fish. Here we have complete absence of quantity. The fish isn't there. So this would be an example of a ratio number.